start working the assignments, because you will be finding new additional no I mean bottlenecks or challenges, and you have to go through it. Okay, so this is what my request to all of you. Yeah.
Yeah, Lakshmi, sure, sure.
Okay, guys. So you guys want to go through these assignments again? You want to have some kind of discussion, or you will complete it and then come back and have a discussion on that?
Lakshmi will do it and then we can have a discussion. We'll
One
complete it
person leader.
and then we'll have a discussion.
Okay. So what about others? Fine, right? What Sunil have suggested.
Yes, yes, Lakshmi. We'll do it.
Yes,
We'll
yes.
do it and then we'll have a discussion.
Okay,
Yeah,
great.
yeah. Yeah, Lakshmi.
So I'll give this week, and then by Saturday, I want to see all of your, responses with your, approach and your analysis on those two assignments. Yeah, and Saturday we'll have a discussion.
Yes, Lakshmi, 100%.
Okay, guys. Yeah. All right. So give me 5 minutes. Let me, pull out today's content, and then we will go start. Yeah, pulled out the data. Let me just take it. Okay. Okay, so I'm going to share some contents to all of you. Okay. Okay, I've created PCA. Inside PCA folder, you'll find some contents. Okay, so let's take out all these contents and you can start referring them. Okay. Okay, so in regression, we have Now we have understood that we can do the multiple linear regression. Sometimes there is not only one variable which is going to help us to predict my linear output or the linear response variables output. Like we have taken how the monthly expenditure of a household family is you know uh, increasing or decreasing based on the gross income of the family, right? So the gross income of the family is not only one variable which is influencing towards the expenditure. There are other factors like number of family members, like how many children's there in the family, or how many people are actually employed, isn't it? Similarly, what else you think? There could be many reasons.
Living cost of that city.
Yes,
Where they're
living
living
cost
in.
of, yeah, so living cost of the city. So these are so many variables. I mean independent variables which also plays a role in predicting your monthly expenditure. So here you can see my independent variables are continuous variables. My output variable or the response variable, this is also a continuous variable. So I can see there is a linear relationship among them, and what I can do is I can build a linear regression model. Okay, since it is not as one variable, so it is a multivariable, so it become a multivariate linear regression, right? Now the linear regression says each independent variables are not related to each other. There should not be any kind of relationship among them, and they should be completely orthogonal to each other. But in practically, is it correct? In practically, you will find these independent variables are actually not independent. They have themselves some sort of relationship. Okay, once the collinearity, or what we say covariance, between or among these independent variables exist, then there is a violation of your linear regression assumption, isn't it? I think we have already discussed about the assumptions, list of the assumptions. True or not?
Alex.
Yes, Lakshmi.
Right. So once these variables we found they are not independent, then how I'm going to solve this problem? Because I wanted to find out what is the monthly expenditure of this family. Based on that, I can tune my marketing agency. Now I can bring out the products. I can try to meet their expectations or their demands in my say it's a retail market or no, retail chain or restaurant, right? Fine. So in this case what I'm trying to find out is I want to find out what will be the actual spending when, even if they have a relationship among themselves in my independent variable list. Okay, so what are the approaches I have told? One approach is you can drop out some of the elements, so which is creating maximum problem. Let's say the number of uh, earning members of a family is actually a culprit, because it have relationship with the size of the family, or it have relationship with the city of preference. So all those things are actually somewhere related to one particular variable. So how I will find out? Now what I need to see is I will first start dropping one element each one time and see is there any accuracy is building up, right? If the problem making guy is removed, the efficiency of the system also improve. Yes or no? Yes
Yeah,
or no?
Lakshmi.
True. So that's where what I will try is the first approach. I will try to find out who is making maximum problem. What is the problem? The multicollinearity problem. I think multicollinearity we have already understood. That is a collinearity matrix where one variable have a correlationship with other variable. Okay. Now, if I find one variable have the, I mean, um, one of the most influencing variable among independent variables, and I can see out the figure. Uh, what is that? Uh, percentage it is influencing. Based on that, what I can decide is, okay, this is the variable I have to drop out. Okay, so like that, what I'll do is till I satisfy, I can start dropping these variables whose multicollinearity is high and see whether the model what I am building is a sensible model or not. Okay, yeah, definitely this model will not be giving you best accuracy because you have dropped out many of the no variables, but it's a sensible model, right? It actually makes sense. The second thing is what I should try to do. The second thing is, if somehow I can remove the multicollinearity problem among these variables, then these variables are going to make a lot of sense and I can build a proper model also, right? So all these approaches we will study today by using VIF, that is something called variance no importance factor, and then we will also study PCA, which is called principal component analysis. Okay, so to start this, what I'm going to do is I will take one example of a car. So let's say we want to buy a car, and definitely what I will see is whether it is having a fuel efficient car or not. If it is a fuel efficient car, then I'll go for it. And how to derive this fuel efficiency? It is not just like that coming, right? It have some kind of variables or factors which influence the efficiency of or the fuel efficiency of your car. Okay, now from the domain point of view, let's all of you just think a little bit, think for 5 minutes and come back and tell me what are the factors actually I will see which is influencing towards the mileage. Okay, so think about it, then we'll go to the problem.
Lakshmi, hello.
Yes.
Lakshmi, regarding this correlation part, uh, like you told, the variables which are correlated, we have to neglect those variables. So, is it the
Hmm.
same as adjusted R square which we are getting output in while doing this one? This
No. Okay, adjusted R square, you are
Hello.
hello, yeah, hello.
I think we lost Lakshmi.
Yes, Sasi, what up? What's up?
Nothing.
Vinod, how are you doing?
I'm doing good, man. I think we lost Lakshmi. Yeah.
Yeah, how are you saying?
Sunil, what about the election data, man?
I'm quite busy man nowadays. I'm not having time for myself also. Man. They are now telling me to learn Linux shell scripting and all. So it's
Hello.
very
Mm-hmm.
difficult now.
Yeah, Aril, tell me. Aril, sorry, man, I was sleeping in the morning.
That's okay. I guess the power just changed, so the generator came on, so I think Wi-Fi. So yeah, that's why probably Lakshmi was the same thing. I guess.
Okay, okay.
Hello.